Subscribe now and press the bell icon. Never miss an update.
Hi guys, this is Anfichan. Welcome to my mathematics class. Let's study today's topic. Today's topic is Arithmetico-Geometric Series. This topic is taken from sequence and series. This topic is one of the important topics, very important, and one of the difficult topics. Let's see firstly what is Arithmetico-Geometric Series. Okay, here I have written in a very simple way the definition of the Arithmetico-Geometric Series. By its name is clear Arithmetico-Geometric Series. So definition says the terms of AP. AP means arithmetic progression, or you can say the arithmetic sequence are A comma A plus D comma A plus 2D comma dot dot dot. So this sequence is called your arithmetic sequence, or you can say this progression is in arithmetic. Right? How we know this sequence in arithmetic progression? Because here you can find out the common difference in between two successive terms. And the second, the terms of GP are 1 comma r square comma dot dot dot. These three numbers and so on are in GP because their common ratio means common ratio is same. Okay, ratio is same. Okay, between successive terms. Okay, ratio. So here let me remind you how to find out the difference. Okay, this upon this, this minus this difference, you can find out this minus this, also you can find out the difference. Okay, you will get the common difference, right? And in this case, okay, ratio, okay, r upon 1 r square upon r, you will get again r. So your common ratio is r. Okay, here ratio will be the constant, here difference will be the constant. Okay, this way we know this sequence is in arithmetic and this sequence is in geometric. Okay, a series of the type a dot 1, this into this plus this into this plus this into this plus dot dot so on. Okay, whose each term is the product of the corresponding terms of an AP and or GP is called your Arithmetico-Geometric Series. This one is known as Arithmetico-Geometric Series, because here each term is the product of corresponding term of AP and GP. So that's why this is known as an Arithmetico-Geometric series. I have taken one example: 1 by 2 plus 2 over 4 plus 3 over 8 plus 4 over 16 plus dot dot dot. One more dot I have taken here. See, this is an Arithmetico-Geometric series. So how to know? Okay, as according to the definition, 1 into 1 upon 2 we can write down, and 2 into 2 upon 4 plus 3 times 1 upon 8 plus 4 times 1 upon 16 plus dot dot. Here you can say here product of corresponding terms of AP and GP. Here also same, because you see 1, 2 and 3 and 4 in GP, geometric progression, half, 1/4, 1/8 and 1/16 comma dot 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 are in here AP, and this one is in GP. Okay, now here a series of type whose term is the product of corresponding term of an AP and GP, right, is known as an Arithmetico-Geometric Series. This example satisfies the definition of Arithmetico-Geometric Series. Okay, so that's why we can say this is an Arithmetico-Geometric Series. So today, okay, I will tell you the how to find the sum to n terms of this type of series. Okay, so sum to n terms. this little bit difficult one, okay, to determine the sum to n terms if the series is arithmetico-geometric series. Okay, so I think in one video I have taught how to find out the sum to infinity if we have arithmetico-geometric series. So you can see. So today I'll teach you how to find out again in a very simple way, a very lucid way, how to find out the sum to n terms if we have arithmetico-geometric series. Okay, so here we go. Now I'm going to tell you how to find out the sum to n terms. So see the procedure properly. First and the first part. Solution given arithmetical geometric series is half plus 2 over 4 plus 3 over 8 plus 4 over 16 plus dot dot. If you observe the series, you will not find here nth term. Firstly, we need to find out the n term of this series, nth term of this series, right? The given arithmetico-geometric series, because we want to find out the sum to n term. So that's why we need firstly nth term. So now I'm going to tell you how to find out the nth term of the series, okay? And let me convert in proper with that is, or you may write down like this way also. 1 times 1 by 2 plus 2 times 1 by 4 plus 3 times 1 by 8 plus 4 times 1 by 16 or 1 over 16. You can write it like this way and so on. Let Tn be the nth term of this series. 1 by 2 plus 2 by 4 plus 3 over 8 plus 4 over 16 plus dot dot. Or then Tn. We can write down like this way because we have two series here. 1, 2, 1, comma, 2, comma, okay. So I sequence 1, comma, 2, comma, 3, comma, 4, comma, dot, dot, dot. These numbers are in AP. So arithmetic sequence you have. So if you see the second term of each half, 1 by 2, 1 by 4, 1 by 8, 1 by 16. Here you can find out ratio same. Means they are in geometric progression. Excuse me. We can write down like this way. Nth term of 1, comma 2, comma 3, comma 4, dot, 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 and times nth term of 1 by 2, comma 1 by 4, comma 1 by 8, comma 1 by 16, dot, dot. So this is a procedure how to find out the nth term of this series. Okay, otherwise, okay, if you know orally, you can do also. So just procedure. You know here 1, 2, 3, 4, they are an AP. Here orally also we can tell because they are going in sort of pattern, in easy pattern 1, 2, 3, 4. Because if we have first term you 1, in second term okay 2, in third term 3, and in fourth term 4. So in fifth term we will have a 5 definitely, and similarly we can say in nth term we will have a n. So easy, right? So instead of this pattern, you will have a little bit difficult one which you cannot easily tell. So what to do? Okay, at the time, okay. So I will tell you the general method, right? So if you have an okay, let me tell you in AP, if you want to find out the nth term, then we can use this formula. a plus n minus 1 d. And if you have a GP, in GP we can find out, okay, nth term by using this formula, a times r raised to power n minus 1. So these two formula you can use, okay. So whatever you have, okay, numbers in AP, it doesn't matter. You can find out very easily nth term, right, of AP. And here in terms of, okay, if you have a sequence in GP, you can find out, okay, by using this formula. Okay, so now why? No panic. You can find out very easily. Okay, so let's move into the next line. Nth term of 1, comma 2, comma 3, comma 4. As I told you, I am going to tell you the general method. A means your first term, N means your nth term. Definitely, D is your common difference. So A1 plus N minus 1. D, what is the common difference here? You're going to get here common difference 1, 1, 1, right? So common difference we can find out using this form is equal to tk plus 1 minus tk. Alright, k is your natural number, okay? And times your 1. Now these numbers, these terms are in GP. So GP's formula is 1 by 2 times R. What is the ratio here? R is equal to 1 by 4 by 1 by 2. So you're going to get here 1 by 4 times 2 upon 1 means 1 by 2. You will have a common ratio also 1 by 2. Here's small bracket within an n minus 1. Okay, so here simply 1 plus 1 n minus 1 you're going to get here times here. We can use law of indices. Here power is 1. I'm going to tell you in a proper way so that you will not have any confusion. And minus 1 plus 1. So again, let me tell you the law of so in this definitely you don't have any problem about the law of indices if you are new one, okay. So if you have forgot, okay, then you can see the law of indices. If we have a basis same, okay, right, and they are in a product, then in result, okay, you will write the same base and power gonna get added, okay, m plus n. Power will be added, okay. You can write down a raised to power m plus 1. Here also same thing is happened as I've done here. This is called the law of indices, okay. In early classes definitely you have studied, so there is no doubt, okay. So 1, okay, 1 plus n minus 1 are very simple calculations. So you're gonna get here n times here 1 minus 1, they will cancel out because they are in same magnitude but in opposite sign, with opposite sign, that's why. And we are going to get only n raised to power n. So we can write down very easily n times, okay, 1 raised to power any power. Any power means natural number, so or any rational, or well, you can get only 1, okay. So 1 raised to power n is 1, 2 raised to power n. Okay, so we can write down in this form. So 2 times n, so we are going to get n over 2 raised to power n. This is your n terms of the series, okay, n terms of the geometric series, sorry, Arithmetico-Geometric Series, okay, easy. Now let's move into the next step. Now how to find out, okay, right? So which method we are going to apply here. Next step, let Sn be the sum to n terms, or sum of first n terms also you can write down, and then you can write down like this way. Sn is equal to 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16 plus dot dot dot. 3 dots are enough, and plus, okay, let me write down, okay, second, sorry, last term firstly, and then we need to write down also second last term, okay. So second last term is very easy. In order to find out the second last term, we replace the n of last term by n minus 1. You just replace, okay. Here n and is replaced by n minus 1 over here also, okay, to raise to power n minus 1. Clear everyone? So definitely clear, okay. So again, okay, let me tell you, suppose if we have a last term, okay, 2n minus 1 upon 2 raised to power n plus 1, then what will be your second last term? As I told you, in order to find out the, again I am repeating the same sentence, in order to find out the second last term, you have to just replace n by n minus 1. It's easy trick. So 2 n minus 1 minus 1 and 2 raised to n minus 1 plus 1. I have just replaced n by n minus 1, and you are going to get here 2n minus 2 minus 1 over 2n. Okay, so finally you can say 2n minus 3 over 2 raised to power n. So this will be your second last term if we have this one last term of any easy. Okay, all right. So okay, let's move here. So easily we have written here second last term also, right? So let's do this one 1. In order to find out the sum to n terms, we need multiply by a common ratio of GP. Common ratio of GP. What is the common ratio of GP? As I told you, 1 by 2, 1 by 4, 1 by 8, 1 by 16, dot dot dot. There in a GP, here common ratio is 1 by 2, as I told you while finding, okay, here, right, nth term of the GP. So now multiplying, after this I'm here. So this is the procedure to find out the n terms of the Arithmetico-Geometric Series. Multiplying 1, or write it like this way, both sides of first means this one, by 1 by 2. 1 by 2 means common ratio, okay. So common ratio of GP, 1 by 2 we get. So just multiply 1 by 2 Sn is equal to 1 by 4 plus 1 by 8 plus 3 by 16 plus 4 by 32 plus dot dot, and plus here n minus 1 over 2 raised to power n. So here listen to it. When you will multiply, okay, this term by 1 by 2, so let me explain here properly, and times 1 by 2, so your next step will be this one, 2n minus 1 times 2. And here you know, if there is a if there you can't see any power, this means there is a 1, okay, definitely 1. N minus 1 over 2 raised to power n minus 1 plus 1. Okay, you will get n minus 1 upon 2n. Just same thing I have done here also. Alright. And plus n by 2 raised to power n times 1 by 2. So here power 1, n plus 1. You will get n over 2 raised to power n plus 1. Alright. So just multiply it. We will get this line. You can say this one is a second. So after this, in easy, we just subtract second from first. So subtraction is not okay in easy way, in simple way, but simple but tricky. So you can, okay, now I'm going to show you subtracting. See very carefully. If you know, once these all steps, procedure, and if you do the very carefully, then definitely, okay, no one can stop to get the result. Okay, subtracting second from first, we have, so I'm going to arrange, see very carefully everyone, Sn 1 by 2 plus 2 by 4 plus 3 by 8 plus 4 by 16 plus dot dot plus n minus 1 over 2 raised to power n minus 1 and plus n upon and over 2 raised to power n Okay. Now, how to write down? Okay, 1 upon 2 Sn. Listen to me. You have to write down 1 upon 4 up to one step. Okay. You have not to start from here. You just start to write down the left part up to one step. Okay. Here. You have to leave one step. So, from here and here plus 1 by 4. That's why I've written here plus 1 by 4, so that you will not have any confusion, plus sign, and plus 1 by 8 and plus, see very carefully, 3 by S3 by 16 plus 4 by 32 plus dot 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 and plus, just exactly in the same way you will write down, so you will not have any confusion to do the next step, and the plus n over to n plus 1. If once you understand, then you can write down the directly also. Subtracting from first, then you can write down the whatever you get result directly. Okay. To make it clear, I'm going to show each and every step here. Just subtracting means you need to change the sign here. Here positive in negative. So this step will come okay as it is. No change there will, and here negative sign, because we are going to subtract negative, and here negative and here also negative, dot dot dot, and negative and positive becomes negative, right? Why we have a change? Because we are going to subtract. Okay. Alright. So let's see here, 1 minus 1 by 2 Sn. You understood, I think, as it is. This will come 1 by 2 and 2. Denominator same, okay, fraction. 2 over 4 minus 1 upon 4. 2 minus plus 1 by 4. And the plus also you are going to get, okay, 3 minus, okay, here I think some mistake, because 1 by 4 and 2 by, this is, okay, we multiplied, okay, this by, okay, multiplying both sides of first by 1 by 2, so we get, okay, 1 by 2 Sn, 1 by 4 plus 2, oh, I missed here 2, so I correct it, 2 by 8, so it's going to be 2 also, right, and 3 minus 2, 1 by 8 plus 4 minus 3 and 1 by 16. Okay, listen to me everybody, okay, in each and every question you will have here same numerator, this way, okay, I got my mistake, right? So here, okay, all right, so firstly by mistake, okay, by mistake I wrote here 1 and 3 minus 1 2, but here 1, and here also I'm getting 1 in numerator, so this shows that, okay, somewhere you have done mistake. Okay, so this way you can find out also, always will get here same, okay, same numerator, right, except, okay, first you have not to compare with this one, you have fortunately, okay, we have right, we have got, okay, here 1, otherwise, okay, even you can have any term here, but after this you will have the same, okay, till here, except last, okay, same numerator. Here dot dot, so here also you can write down, okay, dot dot, this is also dot, just, okay, and here plus n minus, see, n minus n plus 1, and then cancel, you are going to 1 minus 2 raised to power, this minus this, you will get 1 upon 2 raised to power, again here also in numerator we have 1, but in last term you will not get it. Same, minus n over 2 raised to power n plus 1. So clear? Once you do this correctly, then no one can stop you to find out the correct answer. So after this we have to just simplify, right? Just we have to use the formula. Or I'm going to write down here 1 by 2 Sn. So see, from here to here, okay, you can say from here to here, there is a GP. So what is the formula, okay? Sum to n terms in GP. Sn is equal to A 1 minus r raised to power n means number of terms, and 1 minus r, and if r is less than 1, we're going to use this formula, right? As in the same formula I'm going to apply here. So see, a means here 1 by 2, r we have here 1 by 2, ratio also, right? 1 by 2, and number of terms, n means okay number of terms, so you can so count, okay, so 2 power here 1, right? 1 by 2, 1 by 4, so you can see, okay, 1 upon 2, 1 upon 2 square, 1 upon 2 cube, plus 1 upon 4, okay, 2 raised to power 4. If we have a first term, then power 1. If we have a second term in denominator, we have a power 2. If we have a third term, then okay, we have a power in denominator 2 raised to power 3, right? If we have okay here 2 raised to power 4, this means in 4 term we have okay 4 okay, in power 2. This means okay, so here you can make the relation, right, between power and the term. So it will be easy to you count the number of terms. So okay, similarly we here 2 raised to power n we have. So this means okay total we have number of terms n. So how many terms there are? N, okay. Because here power 1, 1 by 2 1, right? And plus 1 upon 2 raised to power 2, and plus 1 upon 2 raised to power 3, and plus so on. Here first term 1, second term 2, third term 3, and fourth term 4. So okay, and then last term 2 raised to power n, 1 upon 2 raised to power n. This means okay total we have from 1 to n, okay. So n term. So how many terms are there? N. So you can make okay relation like this, but I will tell you in other questions also if we get okay different. Sometimes okay, students do mistake here also in counting number of terms, right? Okay, so I'm going to write down the formula. 1 upon 2 here 1 minus r. R means here 1 upon 2 ratio. I told you how to find out. Raised to power we have n terms, so we can write down n. Below n has a ratio. We have 1 minus 1 by 2. So up to here formula, okay, and minus last term. As I told you, okay, up to here, these all terms are in GP. Here n over 2 raised to power n plus 1. Okay, so let me write this formula, okay, since Sn is equal to this one formula, right? You may write down as a reason if you have any problem. Okay, or 1 by 2 Sn. So half, here also you are going to get half. So lack of space, okay, I'm not going to extend, okay. I'm not thinking also. So just okay, going to cancel. I'm writing okay, half. This is also 1 minus half means half. So half are going to be cancelled. So I'm writing okay, 1 minus, as you know, the 1 raised to power n means 1, and over 2 raised to power n minus n over 2 raised to power n plus 1. So simple, okay. You can do very simply. Now just multiply each and every term. Yeah, or you can say just multiply both sides by 2, because we have to remove from here, okay. So you can get, you are going to get okay, or Sn is equal to, so if you multiply by 2, or you can say here you just multiply here also 2, here also 2, here also 2, right? Here also 2, then 2 to cancel, and here you will get Sn. So just here you are going to 2, so and 2 also, this minus 2 upon 2 raised to power n, and minus 2n over 2 raised to power n plus 1. Okay, so you can say this is also final answer, or if you want to simplify, all right, as you wish you can do. So here, or I may write down like this way, 2 minus here 1 upon, by law of indices, 1 upon here power 1. So I may write down like this way also, minus n, here also power n, 2 1, so 1 1 will cancel, so n over 2 raised to power n. So you may write down okay, this also as a result, okay, as okay answer of this, yeah, sum of this series, okay. Or if you want to simplify, all right, if you want to take okay LCM, as you wish, okay, otherwise also this is also simplified form. Okay everybody, I think okay you understood. So these two questions are very easy, so I have left for you for practice. So if you want to get the answer, you can tell me, and definitely okay I will help you. to show the answers of these questions. Okay, and I will take a more difficult one questions of same arithmetical geometric series in next video. Okay, so thank you very much for watching this video and stay with my channel to get more and more mathematical videos. Okay, see you. Bye bye.